Okay, one more. This time we have an e as the base. So e to the x graphs, that's going to look like this. The e to the x graph, I have also done that in the notes as well. So if you look at the table on there, your e again is about 2.7. You can find that on your calculator. It's usually above your ln key. You have an e to the x or e to the caret, which you can do that. But we're going to use transformations on this one. So this is what the base graph looks like. Again, that's in their notes. You can take a look at that and you can see that that's what the base graph looks like. Now we're ready to answer these questions. Horizontal asymptote, number that comes always after the exponent. In this case, it's going to be y equals 1. We want to find our intercepts. So for this, we're going to just go ahead and use the original one. It's already in the proper form. So talking about transformations, let's talk about that first so we see what we expect the graph to look like. Okay, I have a negative out front and a negative here. So if you apply two negatives, then we need to see what the graph looks like. So this is y equals e to the x. Now if I apply the negative on the outside, that's going to make the graph look down like this. This would be y equals e to the, it would be negative e to the x. So I have a negative on the outside. That's the one that does a flip over the horizontal axis, negative on the outside there. Now if I apply another negative, which is going to be here, that means I'm going to take this graph and flip that one over the vertical, which means that the final graph is actually going to look something like this. So right here, this would be y equals negative e to the negative x. Now of course I didn't do any other transformations. I just wanted to keep it based with no left and right and up and down movement. It would basically look like this one here. So my final answer, graph should be going down and looking like that. So my intercept should actually confirm that the shape does in fact go down like that. So let's find the intercepts. X-intercept is where you put in a 0 for y, and we'll set it equal to the whole thing, and I'll just leave this just as the way it is, the negatives just like that. This one I'm going to move this over to the left hand side. Now when you move this term over, it's not going to change the negative in the exponent position. It only changes the one on the outside. The one that's here, that's stuck with the exponent. You can't change that one. So e comes over. I get e raised to negative x plus 2. That's going to equal 1. Now I want to solve this one by equal basis property. We showed how to do this earlier on a previous example. If you have a 1 here, the trick to doing that is you're going to change the 1 into e to the 0. E to the 0 is the same thing as 1. We can make the bases both the same that way. Now that the base is the same, we can now do this. We can take negative times x plus 2. We're going to set that equal to 0. Multiply this out. Negative x minus 2 equals 0. If we add x to both sides, we get negative 2 for x. So we've solved for the x-intercept. That is going to be negative 2. Now we want to solve for the y-intercept. So y-intercept I'll do here. Y-intercept is where you put in a 0 for x. So y-intercept x is equal to 0. We put that into the original one. I have negative e to the negative 0 plus 2 plus 1. And I get negative e to the negative 2 plus 1. This is something that you want to put into your calculator. So again, to do that, you have the little e caret key that's above the ln on your calculator. You want to go ahead and put that in here. You have a negative, and then make sure when you're putting these negatives in your calculator, by the way, calculators will have a minus sign like this, and then you'll have another one that has a negative inside the parentheses. You want to use the one that has the parentheses. That's how you get negatives here. So if you're putting that in your calculator and you're getting error messages, you're probably putting in the minus sign instead of the actual one inside the parentheses. This smaller one here means that you're actually making it negative. So that's what you want to use. If you put that into the calculator, that's going to give you about 0.86. So 0.86 is approximately what that would be by putting all that in there. So that tells me approximately what my y-intercept is going to be. So about 0.86 for that one. So I'm going to put all this information together and do this graph. So first of all, my horizontal asymptote is 1. So that's my horizontal asymptote, a dotted line going through 1 there. There's my intercepts. Crosses the x-axis at negative 2. Crosses the y-axis at 0.86, which is about right here. Okay. Now you might think that the graph goes up like that, but that would be incorrect because we already determined earlier by doing these flips that the graph is supposed to be going down that direction. So the graph is going to follow the dotted line here. It's going to hit these 2 points, and it's going to go straight down and look like that. So now this one matches the form that we should have. So that's why it's important to make sure you know what the transformations are, because having the intercepts there sometimes is not enough information to tell what the graph actually looks like. Sometimes you will have to actually work this out and see what it flips to, and so therefore this is going to have to go down like this, and that would complete your graph.